we can evaluate the kinetic potential and total energies of the hydrogen atom by using the equations that the potential energy at some level n is minus m e to the fourth over 4 epsilon naught squared n squared h squared, and then the kinetic energy for that level would be m e to the fourth over 8 epsilon squared n squared h squared. And then if we add those two, we can say that E sub n would equal minus m e to the fourth over 8 epsilon naught squared n squared h squared. But we also know that the energy of some space is given by HCr, where r is equal to me to the fourth over 8 epsilon naught squared h cubed times c. And so if we equate the two sides of the energy, we find out that m e to the fourth over 8 epsilon naught squared h squared would equal HCr. That's in absolute value. These have the same magnitudes. And if we plug in the values for the constants, we can get 6.626 times 10 to the negative 34 joules second times the speed of light. And if we plug in all the variables for r, we can get that this is 13.6, not 13.6, but the value for r is 1.097 times 10 to the 7th per meter, and that equals 2.179 times 10 to the negative 18th joule, which is the same as about 13.6 electron volts. And now we can say that K sub n, if we take this value, would be 13.6 electron volts over n squared. U sub n would equal negative twice that, so 27.2 electron volts over n squared, and the energy is negative 13.6 electron volts over n squared. So now for the first excited state, that implies that n equals 2, which means K sub 2 is going to equal, if we put 2 in here, we get 13.6 electron volts over 4, which is 3.4 electron volts. U sub 2, following the same, would be negative 6.8 electron volts, and E sub 2 would equal the minus 3.4 electron volts. For the ground level, n would equal 1, and the energy E sub 1 would equal minus 13.6 electron volts. And now we can use the equation that says Hc over lambda equals the change in energies, E2 minus E1, and thus we can say that lambda equals Hc over E2 minus E1, which is, if we plug in, we get 4.136 times 10 to the minus 15 eV second times c, speed of light, over the two energies. E2 is negative 3.40 EVs minus a negative 13.60 EV, and that will give us a wavelength of 1.22 times 10 to the negative 7th meter, or 122 nanometers. This is the wavelength of the Lyman alpha line, the longest wavelength line in the Lyman series of ultraviolet lines in the hydrogen atom.